How does a single click on your phone in New York beam a cat video from a server in Singapore to your screen in milliseconds? How does this global network actually function? Buckle up, because we're diving deep into the tech that powers our digital lives. And trust me, it's way cooler than you think. If you love learning how things are made, smash that subscribe button and hit the bell so you never miss a video. Let's jump in. The internet isn't just one thing. It's a massive global network of networks, like a colossal spider web linking billions of devices. Your phone, your laptop, your smart fridge, even self-driving cars. At its heart, the internet is a system that lets these devices talk to each other, sharing data across the planet in an instant. But how did we build this digital superhighway? It all started in the 1960s with ARPANET, a project funded by the US Department of Defense. They wanted a network that could keep computers connected, even if parts of it were knocked out, like during a war. This decentralized design, where there's no single point of failure, is still the backbone of the internet today. Think about it. Every time you send a tweet or watch a Real How video, you're tapping into a system born from Cold War innovation. Pretty wild, right? Stick around, because we're about to break down the nuts and bolts of how this all works. What's the most surprising thing you've learned about the internet so far? Drop it in the comments. Let's start with the physical stuff, the actual things that make the internet possible. You might think the internet is some magical cloud, but it's built on real, tangible hardware. First up, cables. Massive undersea fiber optic cables crisscross the oceans, carrying data at the speed of light. These cables are thinner than a garden hose, but can transmit terabytes of data per second. Take the Maria cable. Stretching from Virginia to Spain, it handles over 200 terabits per second, enough to stream millions of Netflix shows simultaneously. Then we have data centers, giant warehouses packed with servers. Think of them as the internet's storage units. Companies like Google, Amazon, and Microsoft operate thousands of these centers worldwide, storing your emails, TikToks, and yes, this very video. Each server is a super powerful computer that processes and stores data. Routers and switches act like traffic cops, directing data to the right place. Routers send your Google search to Google's servers, while switches connect devices within a network, like your Wi-Fi router, linking your phone to your laptop. Fun fact, a single data center can use as much power as a small city. Isn't it crazy to think that every time you watch a Real How video, you're tapping into this global network of cables, servers, and routers? If you're geeking out like we are, hit that like button and tell us in the comments which piece of internet hardware blows your mind the most. Now let's dive into how data actually travels across this hardware. When you send a message or load a website, your data doesn't travel as one big chunk. Instead, it's broken into tiny pieces called packets. Think of packets as digital envelopes. Each one carries a small piece of your data, like a single frame of a video, along with instructions on where it's going and how to reassemble it. This process is governed by protocols, and the stars of the show are TCP and IP, Transmission Control Protocol, and Internet Protocol. IP is like the address on the envelope, directing the packet to places like 123 Server Street, Cloud City. TCP ensures all packets arrive in the right order and none get lost. If a packet gets stuck in a slow router, TCP says, "Hey, send that one again." Together, TCP/IP is the language the internet speaks. For example, when you stream this video, it's split into thousands of packets that zip through cables, routers, and servers, then reassemble perfectly on your screen. That's why you can watch in 4K without a hitch. Here's another cool tidbit. Protocols like HTTP, which powers websites, and SMTP, which handles email, all rely on TCP/IP to work. Want to know more about how your favorite apps function? Smash that like button and we'll keep making videos like this. What app do you use most that depends on the internet? Let us know in the comments. So, how do you connect to this global network? Enter internet service providers, or ISPs. Companies like Comcast, AT&T, or Starlink are your gateway to the internet. They maintain the infrastructure, cables, routers, and more that links your home to the digital world. When you pay your internet bill, you're renting access to their network. But how does your device know where to find a website like realhow.com? That's where the domain name system, or DNS, comes in. Think of DNS as the internet's phone book. When you type youtube.com into your browser, DNS translates that name into a numerical IP address, like 172.217.0.46, which points to YouTube's servers. Without DNS, you'd have to memorize strings of numbers for every website. Imagine trying to remember 172.217.0.46 just to watch this video. DNS servers are run by ISPs, tech giants like Google, or even independent providers like Cloudflare. Pro tip: if your internet feels sluggish, try switching to Google's DNS at 8.8.8.8 or Cloudflare's 1.1.1.1. It can make a difference. ISPs also shape your internet experience with things like bandwidth limits or throttling, which is why some days your Netflix buffers more than others. Have you ever had a slow internet day that drove you nuts? Tell us your worst internet horror story in the comments. We've all been there. You've probably heard about the cloud, but what is it? Spoiler, it's not a fluffy cloud in the sky, it's just someone else's servers. When you upload a photo to Google Drive or stream a show on Netflix, you're accessing data stored in massive data centers around the world. The cloud makes the internet scalable, handling billions of users daily. Without it, your favorite apps would grind to a halt. But here's the clever part: content delivery networks, or CDNs. Companies like Netflix and YouTube use CDNS to store copies of their content on servers close to you. So, when you binge watch, the data might come from a server in your city, not across the globe. This cuts lag and buffering. For example, Akamai, a major CDN, has servers in over 130 countries, ensuring this real how video loads lightning fast, no matter where you are. CDNs are why you can stream in HD without waiting. If you're loving this deep dive into how things work, subscribe to Real How and join our community of calls like HTTPS. Protect your data by scrambling it, so hackers can't read it, even if they intercept it. Cybersecurity is baked into the internet's design, with firewalls, VPNs, and constant updates keeping threats at bay. For example, two-factor authentication adds an extra layer of security, like a digital deadbolt. Looking to the future, the internet is evolving fast. Technologies like 5G, satellite internet from Starlink, and even quantum networking promise faster, more accessible connections. Imagine downloading a movie in seconds or connecting remote villages to the web. But there are challenges too: privacy concerns, misinformation, and ensuring everyone has access to this digital world. What do you think the internet will look like in 10 years? Share your predictions in the comments and let's start a conversation. And there you have it, the incredible, complex, and downright awesome way the internet works. From undersea cables to data packets to CDNs, it's a masterpiece of engineering that connects us all. If you love this deep dive, give this video a thumbs up, share it with a friend, and subscribe to Real How for more videos on how the world's coolest things are made. Click that bell to stay updated and check out our other videos for more mind-blowing breakdowns. Thanks for watching, and we'll see you in the next one.